When you're looking to find the exact value for a trigonometric ratio, so sine, cosine, or tangent, and you've been given a point x, y somewhere on your coordinate grid, it's fairly easy to get the trigonometric ratios. Remember, for sine, we've got opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. If you look at my coordinates here, y is going to be representing the opposite of my angle, x is going to be representing the adjacent of my angle, and then we've got this r value that's going to represent the hypotenuse. You can calculate the r value using Pythagoras' theorem. So x squared plus y squared equals r squared. And with an exact value, you don't want to get a decimal answer, you want to leave it in its simplest radical form. To find the sine of the function in the first quadrant, we are going to take the theta from our angle, which is always the one that's with the 0. So whatever angle is touching your 0, that's going to be your theta, just like when we talked about standard position in the last section. So because sine is opposite over hypotenuse, the ratio for sine is going to be y over r. And in the first quadrant, this is going to be a positive value. For cosine, we've got adjacent over hypotenuse, so that's going to be x over r, which is also going to be a positive value. Finally, for tangent, we've got opposite over adjacent, which is going to be y over x, which is going to be a positive value. So in this quadrant, all of our values are going to be positive. Sine, cosine, and tangent will all give us positive values. In the second quadrant, we could label our triangle. We've got r. We know that this side's going to be x, and our opposite's going to be y. And we can see on our coordinate grid, our x in this case is going to be a negative value. So our x is going to be negative. So if I'm trying to find the sine of theta, again I'm doing opposite over hypotenuse, so I've got y over r, which is going to be a positive answer. Now for cosine, I have x over r, but in this case my x has a negative value because I'm in the negative side of x. So it's going to be negative x over r, which is a negative value. And finally, my tangent is going to be y over x, but in this case the x is negative because it's on the negative side of the axis, so it's going to be negative. So in the second quadrant, the only one of our trig functions that's positive is going to be the sine function. In this case, our x is going to be negative and our y is going to be negative because we're a negative into the x-axis and we're also negative on the y-axis. So calculating our exact trigonometric ratios again, for sine, we've got negative y over r, which is a negative value. For cosine, we're going to have negative x over r, which is also a negative value. And for tangent, we're looking at opposite over adjacent. So we've got negative y over negative x, which is going to simplify with the negatives canceling out, so we get positive y over positive x, which is also a positive answer. So in the third quadrant, only our tangent is going to be a positive value. Finally, looking at the fourth quadrant, we can see that our x is going to be a positive value and our y is going to be a negative value. So in the fourth quadrant, our sine is going to be a negative number for y and r, which is a negative. For cosine, we've got a positive value for x over our r, so that's going to be a positive. And finally, for tangent, we have a negative value for y over x, which is going to be negative. In all of our calculations, we took x squared plus y squared to get r squared. And because even if y or x is negative, it's going to turn out to be a positive when we square it, r will always be a positive value. So you can never have a negative value for r. You can only have a negative value for your x if it's on the negative x-axis, or the y if it's on a negative y-axis. So to summarize all that, we can use the CAST rule, C-A-S-T, to tell us whether our trig function is going to be positive. In the first quadrant, all of our functions are going to be positive. So sine, cos, and tan are all positive. In the second quadrant, only sine is positive. In the third quadrant, only tan is positive. and in the fourth quadrant, only cos is positive. So that's on your formula sheet. But it is an easy way to tell where our trig function is going to be positive depending on where we are on our coordinate axis. So just one example. If I want to find the value of theta that's going to satisfy this equation of cos theta equals negative 3 over 4, the first thing I need to decide is where am I on my coordinate axis. So if I remember my cast rule, A, S, T, and C, cosine is only going to be positive in quadrant 1, where all of them are positive. It's also going to be positive in quadrant 4, where only the cosine is positive. Since my cosine is a negative value here, I know my angles could be in quadrant 2, and it also could be in quadrant 3. So now I need to calculate it. So I'm going to find out where is cos theta equal to, now I'm just going to make it positive to figure out the reference angle. So I'm going to go 3 over 4. And then I need to calculate that value. On my calculator, I'm going to do second function cosine because I want to get the angle. And I'm going to go 3 divided by 4. And my calculator is going to give me that my reference angle is 41 degrees. So that means this angle here is 41 and this angle here is 41. So now I can use this reference angle to figure out what my two angles are. So my first angle is going to be 180 minus my reference angle because it's 41 degrees less than that. So 180 minus 41. So that's going to give me 139 degrees. And for my second angle, for the angle in the third quadrant, I'm going to go 180 plus 41, which is going to give me 221 degrees. So the two angles that are going to have a cosine of negative 3 over 4 are going to be 139 degrees and 221 degrees.